More than half of the world's population live in urban areas. This poses a challenge as the increasing number of private vehicles causes greater demand for parking spaces, making it an increasingly valuable asset in most cities. As the number of private vehicles continuously outnumbers existing parking spaces, it leads to several problems including drivers violating parking regulation and developing illegal parking practices in areas that are not designated for parking. In some cases, drivers don't bother checking for an available parking space, thinking that the parking area is already full. But what if there's still one or two available spaces? So there will be insufficient use of space.
But someone will try to search a busy parking lot, roaming around looking for an available parking space, relying purely on luck, only to be left disappointed. The driver would say, I should have not tried. Yeah, and it's really frustrating and can cause stress, leading to a decrease in productivity. Not only that, it can also lead to traffic congestion, contribute to air pollution by emitting unnecessary carbon dioxide, wasting time, and liters of gas. It can decrease the quality of life for people living in urban areas. We need to stop aimlessly circling the block, desperately searching for a parking space.
We need to figure out a way where we can utilize modern technology to provide detailed real-time parking information in an efficient and effective approach. Traditional smart parking systems that use sensor-based provide decent functionality. However, it is not cost-effective. It also requires higher maintenance and it has limited range of tasks. This is why this study will use an IP camera as it is extensively utilized for convenience, including a study of Cuevas that protection of employee vehicles ranked top 5 among 15 indicators in the usefulness of surveillance camera in crimes against property.
Also, you can collect valuable data information on parking patterns, usage, and demand, allowing for better decision-making in regarding parking policy and management. Not to mention, it is way cheaper, and if we integrate this with a smart parking system, well, it's a total game changer.
Computer vision enables computer to analyze and interpret digital video. It's like a device having a human vision capability. It is widely used that even Tesla's autonomous electric vehicles depend solely on computer vision for their self-driving cars instead of utilizing LiDAR sensors. This is primarily because LiDAR are approximately 10 times more expensive than radar sensors. Andrew Karpathy spoke at CPME 2021 virtual conference Computer Vision. The vision system that we have been building over the last few years has been getting so incredibly good it's kinda leaving a lot of other sensors in the dust. And lastly, a simple fact that they mentioned, if a human can drive with vision alone, then a car with cameras all around the vehicle should be able to drive itself with vision alone as well.
We use object detection, one of the most popular computer vision applications, where we need to detect cars in order to detect the availability of parking space. So, a question may arise. Why do we need to use object detection if we can just apply threshold and then count the number of non-zero pixels on each slot for detecting parking space, which is much easier? Even if we ask ChatGPT, it will also suggest to apply threshold. However, it is not applicable for every parking lot. For example, if we try applying threshold in our chosen parking lot, there's too much noise because of the forest edge tiles and shadow buildings and plants. So it's harder to differentiate the availability of each parking lot. This approach, as demonstrated, is inaccurate and unreliable, making it impractical for real-time use as it can cause confusion for future users.
As the pioneer of this big project, we have created a state-of-the-art smart parking system capable of providing in-depth data regarding the availability and exact location of individual parking spots. Moreover, our system is capable of tracking every car across multiple frames, so it can assign unique IDs and can even detect the type and color of each car. Just to clarify, the video we showed was only for demonstration, so we didn't include any colors. But don't worry, we can give the necessary data needed to create the final parking system, which does include color information.
Detecting type and color of each car's main purpose is to provide detailed information for users to easily locate the available spot, as this one is unorganized and unsystematic, so we want to transform the previous into this one, which is much more orderly, organized, and user-friendly interface. In conclusion, smart parking systems are not just a convenience. They are an essential component in creating sustainable, livable, and safe cities. By reducing congestion and pollution, saving time and money, improving safety, and increasing revenue, they offer numerous benefits to drivers, cities, and businesses alike. As one of the initiators of this project, we are hoping to see in the future available parking space signages or maybe in a mobile application where users can check the availability of the parking area in real time. With our smart parking system, finding a parking spot has never been easier, making your daily commute smoother and stress-free.